Alright, so today's weekly contest. First question is we'll solve the first three problems. First question is snake in matrix. Basically, it's a snake game that we used to play in the Nokia mobiles. Uh, we have n, so n represents the n cross n matrix, and the commands right, down, up, and left. So if we notice that if we do a right or a left, only two things can happen. It will go +1 or -1 in terms of n or in terms of the current position. And if it is a up or a down, in that case it will go, let's see, what will it go? It was here, there was a down, it went to 3. So n plus, sorry, whatever the position was 1 plus 2, 3. So it will go either plus n or minus n. So this is a straightforward thing that we can do. I'll do some recursive approach. Probably I'll make unordered map of string and int. This will be basically containing four things. First is right, so that I'll have one, sorry, plus one, yeah, plus one. So let me copy that 4 times. So this will be -1 for left. This will be up, so plus n. So let me take this inside, plus n, and this is down, this is minus n. Okay, alright. Now, what should I do? I should traverse basically. Uh, let's not do the character because it's just too iterative. That'll be nothing but commands current position or answer is equal to 0 initially, and we are given that it never go invalid. The input is generated such that it will never move out of boundary. So the question does the hard part for us already, and I'll just add all the answers on the map. I'll look it up for each command, so that this will give me my answer. This should work. Time complexity should be O of n. Right, there's some mistake. Right, left, up, down. My bad. Up should be minus n. Down should be plus n. Alright, so this should work. Space and time will be O of 1 and O of n. Let's move to the second question. This one has a very weird description. It could have been better. I think the only thing missing is what do they mean. Let me state the question first. The first question is the second question. It states that we are given a tree, so it's not a binary tree. It doesn't have. It can have more than two children, and basically we need to find the size, or we need to find the good nodes. This is a good node if the number of nodes on the left and the number of nodes on the right is equal. This is what the description is trying to say, but it is doing a bad job at it because it states that it wants the size to be equal for all the children to make a node be a good node, but they don't mention properly what is the size, and people can uh, think of size as height here as well, so they get confused. Even I got confused. uh, Basically we need to create a undirected adjacency list, and we'll check for each node recursively if the left or the number of children that we get are having equal sizes, and if it is having equal sizes, we'll return back with one extra size, which is the current node. So this will be having three nodes from the left, or from the one child, and from the other child we'll have three nodes. So that will be same. So it'll count it as a good node. So let's do that using a DFS. I create a adjacency list. This will be integer adj. So one thing to note that is there won't be any cycles, right? So the number of edges present in the edges graph plus one is going to be the number of nodes, right? That's what it is, right? If we have v or we have e edges, then we have e plus one vertices. So that's what we're going to do with. I get n is equal to edges dot size plus one. These are the number of nodes, and I traverse. All right. ADJ, I'll add the outgoing edge as I0. This will be one. This will be, sorry, this will be one. This will be zero. This will be one. I'll need to take care of visited nodes as well, right? So I'll have a vector visited. All right, and this is going to be n in size and zero in initialize as zeros. I'll do a DFS. So I'll have a we can implement DFS in our own ways. So I'll do in my way. DFS call, I'll pass the adjacency list. I'll pass the one that I'm starting from. So we are asked to start from 0, rooted at node 0. So we'll start from 0, and I'll pass the visited vector as well, and return answer DFS. So what I'll be returning, right? I'll be returning, for example, yeah, this is good in terms of highlighting. I'll return from here the edge case will be this is having zero neighbors, right? So I'll return 0 here, and this will return in turn as 1. So I'm keeping on adding 1 as the current node to the whatever size of nodes I'm getting from its neighbors or from its children. So I return that. So before that, let me add the arguments, the adjacency list, and the node, the visited. Let me pass it as a reference. The visited array. If the adjacency the current node's neighbors is not present, then I should return 0. Otherwise, I'll mark it as visited, and I will traverse the various neighbors present. Alright. At this point, I'm traversing all the neighbors, right? And these neighbors will return me its own sizes. Alright. All these sizes must be equal, right? For that, I can check something like a flag. which will be initially 0, and uh, initially the sizes that I'll concatenate and return. So I'll be returning this will contain all the sizes of the neighbors. So by the end I'll return b plus 1, isn't it? Because I'll be adding the current node as well to the concatenated number of nodes, uh, which will be the size for this entire node. So if this is the node and these are the neighbors, this will return 1 here, this will return 1 here. So I'll have 2 here, but I'll return to the above parent 3. So 1 is added because 3 is also counted here. So I will just keep on doing that for each neighbor. So I'll call adj node I and visit it. But before that, let me be careful and check if this already is visited. If it is, then continue. No need to process this. If it is not, let me take this in a int a variable, and if a, or let me also have a variable here t is equal to -1. So at the first, for the first neighbor, I will get something in a, and I'll check if t is equal to -1. Otherwise, I will basically make t is equal to a, and for the all the other neighbors, whatever a value I'll get, I'll check if I'll check here itself if t is not equal to a, which means one of the size is different, then the current node is not a good node. For that, I need to make the flag as 1, so that by the end of the loop, I will know that if flag is equal to 0, which means this is a good node, I'll increment the answer. And meanwhile, I also keep on concatenating whatever size I get, because don't you assume that if I'll have this as not a good node, the above ones cannot be a good node. That's not true, because in this example here, this one is a good node, this one is a good node, this one is not a good node, but this is still a good node, right? So that's what the size is going to do that. Anyways, let's see if this works. And there's an extra brace. It doesn't. Let's see what is missing. So size is equal to 0, I return 0. I am marking it visited always. My bad, I am checking the wrong thing. I should check the neighbor if it is already visited. Let's see if this works now. It should. Time complexity will be, since we are traversing every node once, right? We will be traversing every node once, and we'll be backtracking and returning those respective values. Will be O of n, basically O of e plus v. That's the DFS time complexity, and space complexity will be O of n because we are making the adjacency list. Let's move to the third question. This question states that we are given a nums array and we are asked to return some value. Uh, Let me take this example 232. 232. So basically, the question states that we are to find or we are to divide this current nums into two different arrays such that one array, which is array 1, is increasing, not strictly, but it's increasing, can be equal as well. Suppose this is also a valid array 1. Similarly, array 2 is decreasing, and third point is the sum of each element, array 1 of I plus array 2 of I, is equal to nums of I. So these are the three conditions that should be matching by the end, and however many times we can divide this and get these three conditions to be satisfied, those number of pairs are good pairs, and that's what we are going to return. So right from the beginning, if I try to do this problem, I can have the first value array 1's first element can be what? It can range from the first elements in the nums till that point. So it can start from 0, it can end to 2. By the way, we are told that it's a non-negative integer array, so it can't be less than 0. So from 0 to 2. This is the value range for array 1. So if I bound this, right, or let me do it the less optimized way, and then we'll optimize it. So if I take this one of the value, then the next value that I choose in array 1 is going to be either equal or it should be greater than the last value, right? Similarly for array 2, the value can range from 2 to 0, right? And the next value needs to be greater or smaller. Since it's decreasing, it should be smaller or equal to the last array or last element. So that's how we are going to solve it. It's basically DP, but we can optimize it. But let's do it in the less optimized way first. For that, I will first return solve. This is the method where we are going to process it. We are going to pass nums, the index, the last element, which initially can be what? So for the array 1, even before the first processing, what should be the element for array 1? First element. I should have something which is not going to affect my answer, and that should be the smallest value that is possible, and that can be 0. Right? So I'll pass 0. Similarly for array 2, the greatest value that is possible, which is not going to affect my answer, that can be 51, 50 even. So I'll return integer. I'll pass the arguments. This will be the back value for array 1, the last value of array 1. We'll call it array 1b, and this is the back value for array 2. We don't need to form the array. By the end, we are just to return the permutation or the number of counts, number of pairs. If index is greater than equal to nums or size, in that case I have reached the end, so I should return by the end. If I have reached, then I must have satisfied all the condition and reached here, so I should return 1. Otherwise I'm going to call for all the other values, right? That is basically 0 to, or whatever the value. So here is going to be a loop, right? That is going to decide the next value for array1, and array2 will be bounded by it because I have the third condition here. So I don't need to worry about array2 value. If I select one array1 value, then the array2 value gets decided on its own. So here, if I select array1 value, what can be those values? It can be from 0 till the number index which we are at, right? So if my last array1b was this, so it can be either equal to array1 of b, or it can go till nums of index. So this is the range. If so, this is the range, but I need to make sure that the next, array 2 is not, breaking its this condition, that is, it should be decreasing. So what is the array 1 value that I have right now? Because I have decided array 1 uh, b value, that is going to be I. So in that case, nums of index minus I is my array 2b value, which should be decreasing, right? So the last value was array 2b. Now it's this. So it should be decreasing. So in that case, this is what I need to follow. It can be equal. Alright. And here I'm going to call it for the next function or next call, which is going to be nums index plus 1, whatever the last value now is, that is I. And finally, let me take this into a variable, new array 2b, which is, let me also call this as new array 1b, new array 1b, new array 1b, and this is going to be nums of index minus new array 1. Alright, and this should be less than equal to the last array 2b, and I'm going to pass this and this. Alright, and I'm going to concatenate or collect my answer. This should work, but we need to memoize it, and because this will give us time limit exceed. So for that, it's pretty straightforward. I can create a cache. Since there are 3 variables, I can create a cache, and that will be a 3D cache. There's a better way, we'll get to that, but for now, this is the cache we are going to create. That'll be int n is equal to nums dot size, and n comma vector of int, sorry, vector of int, and this is going to have 51. Similarly, the last vector of int is going to have 51 again, and it will have -1 value. We'll pass the cache. I'll pass it in the argument, and I'll call it, pass it here as well. I'll check if the cache of array 1b, sorry, index array 1b array 2t is not equal to -1. In that case, I'll return here and I will do this. Finally, I think this should work. My bad. This should be n plus 1. And let's see if this works. It does. It'll actually pass as well, I think. Oh my bad. There's the modulo that I have not done. I need to mod the answers every time I collect in my answer. So that will be 1e9 plus 7. And I'll do it here. For each collection, I'll do a mod. Let's see if this works. It does, but we can do something better because we see that this array 2b is essentially, you know, uh, it's bounded by array 1b. So if I fix array 1b, then I don't need this as my state, right? So I can remove this, get array 1b here, sorry 2b here by what? By nums of index minus basically this same thing that I'm doing here, but now it's removed from the stage, so I have less one less thing to worry. I can just have a 2D DP now, and let me remove this, and let me remove this. This is the 2D DP. I don't need this. I don't need this. And just one thing I need to make sure that uh, this should not be negative, right? Array 1b when I'm first passing, actually initially array 2b I was passing as 100 and what 100 and I think this is good. I don't need to do that. I think now I'm not passing this. Now I don't need this. I Yeah, I think this is good. Let's see if this works. Oh, this is not, I'm not passing it this time. Yeah, I think I should, since I was passing 50 here, I should, first time when I pass. Oh, actually, this is the last array to be, right? Which should be this basically, but I should do this only when index -1 is greater than 0. So before that, I should initialize it with 50, and if index is greater than equal to 0, and this will be valid then, and I can just take it here, and should be greater than 0, not equal to, and I think this is good. Let's see if this works. It does. And in terms of time complexity, it will be O of n square, I think. If I'm not mistaken, I think it will be O of n cube because we are having a loop here as well. And memoization is going to take up space for O of n square. Since this is constant, I don't need to worry about that. So this will be O of n as well. And that's it. Thanks, guys.